It's the Growing for Market podcast.
This year, actually, we're looking at our first generation of hybrids that we've made from lines that we started developing 3 years ago. So we'll get a first look at these this summer. But everything that we're trialing derives from crosses between an actual heirloom variety in terms of the parental lines, not the hybrids themselves, but the parental lines were derived from crosses between heirloom varieties and then a Cornell breeding line with disease resistance to most of the important diseases in the field in the Northeast. So late blight, early blight, Septoria leaf spot, fusarium, verticillium, bacterial speck. They have a really comprehensive disease resistance package, and we're trying to get as much of that as possible into what we're developing, although it takes time. So it might be a while until we have things that have all of those in one package.
Hello, and welcome to the Growing for Market podcast, where we talk about growing, marketing, and the business of growing flowers and vegetables for local markets. I'm Andrew Mefford, your host and the editor of Growing for Market magazine, proudly celebrating 35 years in 2026 as the magazine by and for vegetable and flower market farmers. If you're enjoying the podcast, just wait till you see the magazine. Go to growingformarket.com for more. Also, if you could give us a follow and a rating, it really helps other like-minded people find the podcast. And now, let's take a minute to hear from our sponsors. It's with their generous support that we can bring you the podcast for free.
Kate here from Foraged and Sown.
Tanner Johnson, Theo's Harvest.
Emily at Frayed Knot Farm.
David Morkel from Morkel Meadows.
Having healthy transplants is really important.
And since we started using tilth, our plants look so much better.
Year after year, just makes everything easier.
The release of the nutrients in the compost base, we find the amount of juice perfect.
They're coming out of the nursery so much faster.
Germinate well, but also build really healthy rootstock.
Healthy plants, whether they're just staying in the cell trays for a couple of weeks, or if the plants are staying in pots for a couple of months.
We are able to have a little bit more flexibility in when we get the transplants out. Seedlings can last a lot longer in the trays without having to add fertility.
I just can't say enough.
And that's what tilth soil is for us, is it's that top tier tool, and it's been exactly what we need it to be. It's been forgiving. It's been scalable.
It's just been a great partnership.
It's been a total game changer. We're super grateful for the work they're doing at Tilth.
Seven Springs Farm Supply is a farm-based supply company focused on serving market gardeners and has been in business for 35 years. Their catalog includes a comprehensive selection of approved for organic fertilizers, pest and disease controls, growing mixes, cover crop seed, and more. They offer custom fertilizer blending and seasonal cooperative purchasing opportunities, and their experienced team is ready to help guide you to the best solution for your farm's needs. Growing for Market listeners are eligible for an exclusive discount. Visit sevenspringsfarm.com/GFM or give them a call at 540-651-3228. That's sevenspringsfarm.com/GFM for an exclusive discount. Today, we have the pleasure of welcoming Greg Vogel to the Growing for Market podcast. Greg is an assistant professor of plant breeding and genetics at Cornell University. Specifically, Greg has been trialing heirlooms and Hylooms in the open field and, perhaps not surprisingly, finding higher marketable yields in Hylooms due to issues like cracking and catfacing in the heirlooms. His breeding program is working mostly on breeding Hyloom types for the open field, including determinate types in different color combinations. So without further ado, welcome to the Growing for Market podcast, Greg.
Thanks, Andrew. Thanks for having me.
Yeah, well, I'm very excited to talk to you because tomatoes are my favorite crop. And also, I used to have a job trialing the kinds of tomatoes that you're breeding. So this interview is about you, but just to fill both for your benefit and the audience. I know I've mentioned it on the podcast before. So one thing that I did for 7 years was to do trialing for Johnny's Selected Seeds. Like my farm is here in Central Maine, and the Johnny's trial farm is about 35 minutes away. And so it's just serendipitous. We happened to move here to Central Maine and then just happened to get a job working for Johnny's. And so, in fact, I remember the time, it was probably close to the end of my time working at Johnny's when we started getting these Hyloom tomatoes, which I think most people will know that abbreviation to mean tomato that has heirloom flavor and looks, but has improved disease resistance or other features about it. And I remember getting the first groups of heirlooms coming in to the trialing program there at Johnny's and really liking them, noticing improved disease resistance and fewer seconds and stuff like that. And so I recommended that we added some of them to the catalog. And I remember having a meeting about what to call these tomatoes. And so one of my colleagues named Anthony, sorry, Anthony, I forget your last name. I'm sure he listens to the pod. I'm going to get a nasty gram from him, but sorry for forgetting your last name, Anthony. But so one of our commercial salespeople there at Johnny's was like, we should call them Hylooms. And I seem to remember saying something like, well, it's a lot better than hairbrids. And so I don't know if that was like officially what, like if he, that's where the name started, although it's such an obvious combination. I wouldn't be surprised if it came from somewhere else, but I remember like having to decide what to call them because we were putting a group into the catalog. Like the ones that first came across my desk were more like greenhouse types. They're the series. There's like Margold, Marbon, Marnero. Like there's even more. There's this whole Mar series that I know you can get from Johnny's and perhaps other seed companies. I'm not sure, but they might be with other seed companies too. And so we liked those a lot, and they're still available there. If people want, they can still get them. And so we went with that name Hylooms just because it made so much sense. So I can't wait to hear how Hyloom breeding looks from the breeding side of things. So, hey, can you tell us a bit about how you got interested in plant breeding?
Yeah, sure. So I'll just mention, because you mentioned it, tomatoes are also my favorite crop. So I feel very fortunate to be able to work on them professionally now. I'm sure you probably felt the same way when you were working for Johnny's. But I guess I'll kind of go way back. I grew up in the suburbs of Washington, D.C. But, when I was a teenager, I got really into gardening and vegetable gardening. And, I didn't really realize what this meant in terms of like my career interest, but I was really into like looking at seed catalogs and looking at all the different varieties and choosing the tomato varieties that I would plant in the garden for next year. And then, when I got close to graduating from high school, I realized that, I really wanted to get some like more practical experience in what vegetable production would look like, what vegetable farming would look like. So I worked when I was in high school at a farmer's market in DC for a farm called New Morning Farm, who are in South Central Pennsylvania. They've been selling organic produce in DC since I think the 70s.
Yeah, we've had Jim Crawford on the pod.
Have you been
really?
on it?
Yeah.
Oh wow, I have to listen to that episode. I mean, yeah. So Jim is someone who's had, I would say, an outsized impact in my life in terms of inspiring me or influencing me.
Yeah, great guy.
Really great guy. And so when I was to graduate from high school, I just asked him if I could work at the farm for a little bit and see what that was like. And he invited me to go and, check it out a few days, see if it was a good fit. And I loved it. So I ended up working for the rest of that season after I graduated high school, that fall 2009. Incidentally, also a year of a terrible late blight epidemic. So I got to also firsthand kind of see like the effect that plant diseases can have on farmers' ability to profit, to successfully grow a crop. And I also got to understand the importance of disease resistance, right? Like at that point in time, there probably weren't many late blight resistant varieties that were commercially available. There was a lot of breeding after that. And, now there are many late blight resistant tomato varieties that are on the market. So that experience was very foundational for me. I went on to study agronomy in college at the University of Wisconsin-Madison. When I was there, I got a job as a student working in the lab of Dr. Irwin Goldman, who breeds carrots, beets, and onions, and another person with a really outsized influence in kind of my life and career trajectory. I love that experience, and that's when I really realized I wanted to be a vegetable breeder.
Oh, that is so cool. Okay, this isn't really relevant to the interview, but I got to ask where you grew up in the suburbs of DC, because I grew up in Falls Church, Virginia.
Oh, okay. I'm from Silver Spring, Maryland.
Okay. Yeah, I know right where that is. Yeah, it sounds like we definitely have some similarities there, because actually before the interview, when we were chatting, I mentioned that our first farm that we started was on some family land in Pennsylvania. So that was very close to where New Morning Farm was.
Oh,
and
really?
So
where was that?
It was a little tiny town called Shade Gap, Pennsylvania.
Oh, that's super close.
Yeah. Because of that, I guess we got to know Jim, and it was really figured prominently in our plans for that farm to sell to the Tuscarora Organic Growers Co-op, which I think is no longer going, but it was it was doing a lot of business back in that time. And yeah, Jim is like amazing. I didn't do the interview. In fact, one of our other hosts did the interview, but of course I listened to it. Yeah, Jim I feel like he's just did a lot for market farming, and like going back to this, I want to, 70s or early 80s or something like that. He was definitely like a foundational person in that area. So that's really cool. And one other thing I got to bring up is that, that late blight year, I guess, it was 2009, because I feel like that late blight year, so people who aren't in the mid-Atlantic and Northeast might not know what we're talking about here. But so that, I guess that was the year you were at New Morning, and that was our first year farming up here in Maine. And so I guess what to tell people about that is that late blight is, I think, a lot more common in the southern United States, and it tends to start in the South and work its way up through the country. But Maine is far enough north, they didn't usually get a lot of late blight, or a lot of times it was like potato. It was more active on potato than the races that attacked tomatoes very hard. And so I don't know if they've ever proven exactly where it came in. Like, there's this theory that some late blight of infected plants got shipped into the New England region, and then it just spread from there, because in my mind 2009 was like tomato-geddon, because almost it's like this disease that I don't know if they were more used to it in Pennsylvania where you were with New Morning, but up here in Maine where we were, people weren't really used to getting bad late blight infections. And that year, it pretty much wiped out anybody's tomatoes that weren't either sprayed heavily or in greenhouses. Yeah. And so, I mean, actually, I think of that as I count my lucky stars, actually, that I was working for Johnny's at that time, because I think tomatoes would have been one of our big money makers that year. And so to be starting a new farm over, and I remember it hit us around the time that our first tomatoes were just starting to ripen, just wiped them out. Yeah. So we had basically zero tomato income that year. And so I want to loop that back to the breeding, because I think having that kind of experience, just like profound, complete crop loss due to, one single disease, like that will hammer home the importance of disease resistance and breeding, for those disease resistances to anybody who's been through that kind of experience. And as you pointed out, right after that year, a lot of energy, I'd say more energy went into breeding late blight resistant tomatoes. I know, like, because I was working with the breeders at Johnny's at the time, I know immediately went to like super high priority in their breeding program. It was probably the Cornell breeding programs of the time, and everybody else. But I think that whole tale illustrates the importance of breeding, good plant breeding for disease resistance. So. Okay, well, that's really cool. I enjoyed that. I didn't even know that we had that connection. So that's a really fun connection.
Yeah. It is interesting. It's a small world, I guess, huh?
Yeah, it is.
But I guess, certain people tend to have an impact or influence on many others, right? And so certain mentors I've had in my life, have also been influential for many other people that I've met over the years. Yeah.
Actually, that's a really good point. I mean, I would definitely count myself as being influenced by Jim Crawford, even secondarily, just knowing him. He was always very sharing as far as, knowledge to us as younger farmers in the area. And so even though I didn't work at his farm, definitely profited from his ideas, and he's definitely a big person in that mid-Atlantic area. All right, so when I did my homework for this interview, one thing that didn't surprise me was that you do trialing in addition to breeding, because I feel like those two things go hand in hand. Specifically, you have to trial what is currently available in order to know whether the varieties you're breeding are better or not. Okay, so you shared with me the 2025 Cornell Hyloom trial report, which was very interesting. My takeaway from your 2025 trial was that the true heirlooms you used, pink brandywine, Cherokee purple, and striped German in that trial, all had pretty low rates of number one fruit, roughly between 17 and 22% respectively. And flavor was fairly comparable between the heirlooms and the Hylooms. Can you summarize how you did that trial for those who haven't read the report like I have? And is that too much of an oversimplification? And are there any other takeaways from your 2025 trial that would be useful for farmers?
That was a pretty good summary. I think that takes away most of what I could say about it. But no, I'll give you more details. Yeah, like you said, trialing is very important, both for us internally, because we want to compare whatever we're breeding to what's already commercially available. And then it's also part of the mission of my program. I have an extension appointment with Cornell. So part of my job is to, generate information that can be useful to stakeholders. In my case, those are farmers, gardeners, and then members of the seed industry, and then disseminate that information. So we also try to produce this trial data, not only for it to influence our own breeding program, but also to share it with other people who it might be useful for. So the Hyloom trialing is one area we've been doing over the past couple of years. We've been trialing specifically in the open field, not in a high tunnel, for a few reasons. One, you mentioned this earlier, but a lot of the Hyloom varieties, these specialty varieties that have that heirloom appearance, but are like modern hybrids, were bred specifically for greenhouses. There are fewer options that were bred intentionally for the open field. And we did a survey of farmers in New York when I first started in 2023. And we found that many were specifically interested in options for the open field. And so we wanted to generate information that would be, useful to those folks. So yeah, the past couple of years, we've been trialing a few heirloom checks. Last year, we chose 3 varieties that, I would say are among the most popular. We chose Brandywine, Cherokee Purple, and Striped German. Also happen to be 3 varieties that I personally like a lot myself and I've always grown in my garden. And we evaluated 16 Hylooms in comparison to these 3 heirlooms. So these were planted at Cornell's vegetable research farm in Freeville, New York, about 10 miles from Ithaca. We grew them under, I would say, pretty standard raised beds, plasticulture, drip irrigation, a stake and weave trellis with 6-foot stakes. We have every variety represented by 3 different plots in the field, and each plot is 5 plants, so 15 plants for each variety. And then we harvest the fruit weekly for 5 weeks. We weigh the entire harvest. We separate it into grade 1 fruit, and then we lump everything else into non-grade 1. So that would include seconds and non-marketable fruit, just to make our lives a little easier. We rate the incidence of specific defects. So catfacing versus cracking versus large stem scar, for example. And then on a subset of fruit, we take some quality ratings like soluble solids, which is a measurement that correlates with sugar content or sweetness. It's not the only thing that drives flavor. Flavor is very complicated, but oftentimes people tend to think that varieties with higher soluble solids taste better. And then we also invited people at a field day to taste everything. We chopped everything up, gave them forms, and had them do flavor ratings, just 0 to 10 ratings on the flavor. And then we collected that data as well. So to summarize the results, you stated it pretty well. Every single Hyloom variety did better than the heirlooms in terms of the proportion of their fruit that was number 1. So the 3 heirloom varieties averaged, like you said, I think, something like 15 to 20% fruit number 1, which means that in these conditions where we trialed them, only 1 out of every 5 fruit from these plants was, free of bad cracking or catfacing or other defects, which obviously is not great from a commercial farming perspective. The Hylooms ranged from something like 30%, like a slight improvement, all the way up to like 80%, pretty significant improvement. In terms of flavor, we saw a different pattern. With flavor, the heirlooms did rank highly, like in the subjective flavor ratings that participants assigned them. But there were some Hyloom varieties that ranked just as high, or in a few cases ranked higher. So my takeaway from the trial is it is possible to have the best of like all worlds. You can have the better marketable yield, and you can have the flavor, and you can have the disease resistance. It's tough to do, and not all varieties have all of those things, but some do. And I think as we move forward, there will be more varieties that are being released that will match all of those different areas.
And now let's take a minute to hear from our sponsors. It's with their generous support that we can bring you the podcast for free.
Hey, it's Lindsay from Grown By. There are a lot of farm sales platforms out there, but there's only one that's cooperatively owned by farmers. And that's Grown By, your all-in-one solution to simplify farm sales. I'm proud and excited to share 2 new features now available on top of the tools you already know and love. Number 1, our customizable CSA box builder. It allows your customers to simply say what they'd like in their share, and Grown by matches their preferences with your weekly harvest. Number 2, our new wholesale-only marketplace. Developed with the Culinary Institute of America, it makes your life easier with a dedicated shop for your wholesale customers. No more texting those chefs. Combining retail and wholesale inventories and records. And, drumroll, automatic payments on due dates. No more chasing down late payments. These new features sit alongside our popular online sales and traditional subscription CSA tools, making it easier than ever to manage your farm's business. As you start to get ready for next season, we'd love to hear from you and see if our cooperative can be a partner in growing your farm. Visit us at grownby.com. That's GROWNBY.com.
This episode is sponsored by Nifty Hoops. Nifty Hoops designs and builds high tunnel systems for growers who want dependable results. What stands out is that Nifty Hoops tunnels are complete systems designed by experienced builders with the details worked out ahead of time. That means the core components are included from the start, like end walls, ventilation, doors, baseboards, and double-layer poly, rather than being added later. The tunnels are designed for real wind and snow loads, efficient assembly, and long service life. You can choose a self-build kit with guidance from written manuals and videos, or a community build where Nifty Hoops works alongside you and the project gets completed in one day. Nifty Hoops has built more than 1,500 hoop houses across the country, including many funded through the NRCS High Tunnel Initiative. They're known nationwide for predictable outcomes and ongoing support. If you're planning a high tunnel project and want it done right, you can learn more at niftyhoops.com. And now, back to the show. Well, that's a good point that you make about the first sort of heirlooms that I was aware of, or at least the ones that came across my desk while I was working at Johnny's, being for greenhouse. And so I don't know why that is. I mean, but I like what you said about them keeping the flavor, because that was sort of like our thought. We were like, well, this is interesting, but they've got to have the flavor, right? Because if you roll out some tomatoes that look like heirlooms but taste bad, you're just going to destroy that whole, market segment. So,
exactly.
Okay, so that was our first question. Like when they came to me, and so I could put them in a trial, because I was doing pretty big trials. I mean, I think I grew them out in the field too, and so I would, a lot of those years, I think in the field, sometimes I would have 200 or 300 varieties of tomatoes in a field trial.
Oh, wow.
And and of course, like that's across a lot of different types, and
right,
like cherry tomatoes, grape tomatoes, beefsteak, people can think of all the different types of tomatoes. So that sounds like a lot. I mean, that was a lot, but people buy a lot of tomato seeds. And then I was also having greenhouse trials going at the same time, where I feel like, I don't have the records. Johnny's owns them, but it was like 40 or 50. I would have like 40 or 50 varieties a lot of times, top varieties. And then I would usually also run a rootstock trial just to look at, evaluate new rootstocks. And so, but yeah, for whatever reason, it does make me wonder now why they started working on greenhouse types first, but that was useful. So, well, I guess I should say that whole time that I was working for Johnny's, we also had, a farm going at home. Like my wife was working here full time with apprentices, keeping the farm running. And I was just kind of like doing what I could on evenings and weekends. And, what I noticed is that when we grew true heirlooms in the greenhouse, we were getting like half of the yield off of them compared to our like true greenhouse types, like red, like greenhouse slicers. So obviously the economics of that don't work out. We always grew them because A, I like them. B, we had some customers that really liked them, but still the fact that we are getting 50% as much number one sellable fruit off of the heirloom types. And we were grafting them also. Like we were doing everything we could to maximize their yield. But even grafted heirlooms versus grafted greenhouse types, we were still harvesting half of the marketable yield off of the heirloom types. And obviously we can't sell them for twice as much. So, it's tough to make the economics work on those. So that's why when I saw that the like Hyloom varieties come through, I was like, this could be really valuable to help somebody raise that percentage of marketable fruit, since it's never going to be as much as like greenhouse type. So, hey, I was wondering, I know you sent me that study as a PDF. Is that publicly available? Like, is that something I could get a link to and put in the show notes and share in case people are interested, or not? I mean, it's fine. I just thought I'd ask if that is something that's open to the public.
Yeah, so we disseminated it this winter through some outlets that we have in terms of listservs and extension publications that different groups with Cornell Cooperative Extension publish. It's not hosted on a website right now, and the reason is that we're finishing getting my lab's website online. Hopefully this summer, knock on wood, we have a break in terms of the field work to finish that, but it will be up there as soon as the website goes online. But if anyone wants to reach out to me directly, email, phone, that information is on my Cornell page. If you search my name in Cornell, you'll get a link to it. And if anyone reaches out, I'll share that with them directly. But otherwise, it'll be hosted on our website, hopefully this summer.
Okay, cool. I think the takeaways, as you stated, I mean, you like said the takeaways. I was just thinking in case anybody wants to look, if someone wants to get nerdy about it, they might want to check it out. So do you have data for similar Hyloom types that you're working on, or is like what you have in that study?
Yeah, so we are also breeding in this category. We breed in a few different types. We also breed standard, determinate, round, red types. And then another focus, like you said, is the Hyloom types. And we're breeding both indeterminate and determinate Hylooms based on some of the feedback that we've gotten from growers about their interest, and also some gaps in terms of what's like currently available in the market. I joined Cornell as a assistant professor in 2023, so I'm coming on 3 years into my position. So this year, actually, we're looking at our first generation of hybrids that we've made from lines that we started developing 3 years ago. So we'll get our first look at these this summer. But everything that we're trialing derives from crosses between an actual heirloom variety, in terms of the parental lines, not the hybrids themselves, but the parental lines were derived from crosses between heirloom varieties and then a Cornell breeding line with disease resistance to most of the important diseases in the field in the Northeast. So late blight, early blight, septoria leaf spot, fusarium, verticillium, bacterial speck. They have a really comprehensive disease resistance package, and we're trying to get as much of that as possible into what we're developing, although it takes time. So it might be a while until we have things that have all of those in one package.
Yes, I realize that breeding is playing the long game. And so, yeah, it's not like can't expect to like come into the job and have some varieties ready to go the next year. Okay, so it sounds like there's no varieties out of your program that are commercialized yet. But I know the breeding program there has a long history. Like we were talking, I think you said you took over from Martha Muchler, which I don't know if people are in breeding circles or anything may know she was a breeder there for many years. In fact, I mentioned we got material from her to trial certainly back when I was working at Johnny's. So I was just curious. Okay, so there no you haven't commercialized any Hylooms yet.
That's correct. Although, yeah, like you said, there's been tomato breeding at Cornell going back into like the 1940s. So you could say, inherited my program from Martha, who worked as a tomato breeder here for, I think around 40 years or so. And she did a lot of different things. She worked on a lot of different projects. One of the big areas of focus for her was disease resistance. She did release some varieties directly or in collaboration with others. So if you're familiar with Iron Lady, for example, that's a variety that she released maybe 10, 15 years ago, which had resistance to early blight, late blight, and septoria leaf spot, which was, I think a big deal to have all that in one variety. It was the first variety to have all of those resistances. And then she also released material to seed companies, and then they crossed with her material. So a lot of other varieties that are commercially available, you wouldn't know that they have Cornell genetics in them, but they do, because the seed companies collaborate with the university breeders.
Okay. You mean that the seed companies like license that, like what you were saying, that like disease resistant lines or something that Cornell has, let's say like they want to breed an early blight resistant tomato, and Cornell's like, hey, we've got early blight resistant tomato lines, and they'll license it from Cornell. Is that how it works?
Yeah, exactly. Cornell's not a seed company, right? So we don't produce seed and market it and sell it. we develop germplasm or lines, genetic material that then gets licensed to seed companies who do all of those things. And it can happen in a few different ways. Cornell can, or other universities can directly develop a variety, and then a seed company can license that variety and sell that variety. Or, maybe a university program will really focus on one trait, like a disease resistance. But then the line that they develop won't have the yield or the flavor or the fruit size. So then a company will license the line, cross with it, select for the disease resistance, but also select for all the other things that they're good at selecting for, the yield and the flavor, etc. Typically, in either case, the university will negotiate a deal with the company where some proportion of the revenue from the seed sales goes back to the university in the form of a royalty to support further breeding efforts. And that's how the work that we do gets out into the real world and into the hands of farmers and gardeners. It's through working with seed companies.
Yeah, okay. Okay, because I think High Mowing Seeds, I don't know if they're still selling it, but didn't High Mowing sell Iron Lady? There might be others too, but yeah, I'm pretty okay. That's what I was thinking.
At least, yeah.
Okay. Well, check your seed catalogs, folks. I'm pretty sure I remember seeing Iron Lady and High Mowing, so I can't keep up with this stuff. I can't remember if they're still selling it or not, but it would be one place to look. Maybe, perhaps others. I'm glad you explained that, because I feel like breeding is almost like a hidden part of farming, that there's a lot of work that goes on behind the scenes to create the varieties that people probably don't even realize that goes into it. Because I hope to get into this a little more into later in the interview, but there's a lot of technical stuff that goes into breeding, getting as far as making sure that the varieties do what we hope that they do. And so, that seems like a good thing for a place like Cornell and labs to do that work to develop, let's say, so like you were talking about, I don't know if you would call them parent lines, or like maybe like you have like a line that has a lot of disease resistances, and a seed company wants to breed tomatoes with a lot of disease resistances. Like you said, they can license it from Cornell, use a parent that you developed, as one half of a hybrid cross, and where hopefully you make that cross with, let's say, a Cornell disease resistant variety, and maybe a seed company has their own breeding line, which often is not named. They often have like numbers or something like that, because like a lot of companies that are doing breeding have a lot of lines going, if you think of all the different variations on tomatoes. Yeah. So, it's not like these aren't like named varieties. Like they probably, they may have like a line that has really good late plate resistance, or a line that has really good flavor. And so they might try it and cross a variety that has a really good flavor with a Cornell line that has a broad disease resistance package. So hopefully the offspring has the good flavor from the seed company parent and the broad disease resistance of the Cornell parent, or something like that. Okay.
Exactly. Yep.
Okay. So it's like taking the seed company version and combining it with the Cornell version. It's like having a Ram truck that has a Cummins diesel in it. It's like
sure.
The final product is a product of both companies' work, and they're hopefully better for both of them. Okay.
Exactly. It's a good analogy.
Okay, so you may have already said this, but I did want to ask you just like what the goals are for your breeding program. I mean, you mentioned disease resistance, and is there anything more that you want to say about the goals, right? Like you're not out there just making random crosses. Like what are you trying to, is there anything more you want to say about what you're trying to make breeding wise?
Yeah, sure. And maybe I'll first put it into context by just talking about like tomato production in the US and the way the seed companies work and what a lot of them are selecting for.
Yeah, please.
So in terms of tomato acreage, for example, there's about every year in California, there's maybe somewhere between 200 to 300,000 acres of tomato. That's predominantly for processing, for turning into like ketchup and tomato sauce and other products. So obviously huge amount of production in California, very different market, very different climate. There's also a lot in the Southeast, like in Florida. Florida every year might grow somewhere around 25,000 acres of tomato. And that's predominantly in the non-summer months, right? The rest of the year when we can't grow tomatoes in the rest of the country, and that's getting shipped across the country, going into like food service, going into like fast food restaurants, etc. New York, for comparison, according to the USDA statistics, which I think it might be undercounted slightly, but according to the USDA, New York grows about 2,000 acres of tomato. So Florida is like 10% of the acreage of California, and then New York is like 10% of the acreage of Florida. And in many of the seed companies, they might have one fresh market tomato breeder for like all of North America, which includes Mexico and the US. So they're going to focus on those areas where there's a higher like concentration of value. They can get more bang for their buck in terms of what they invest in R&D. So a lot of the unique needs that we have in the Northeast are not necessarily the areas of focus for a lot of the big seed companies. And that's not to say that there aren't seed companies that are breeding vegetables for the Northeast. There are. I mean, you talk about Johnny's. Johnny's is an amazing company that's breeding varieties for the Northeast and selecting and selling varieties for the Northeast. And there are other excellent breeders who are doing the same thing too. But overall, the amount of investment for the Northeast is smaller. That being said, there's still thousands of farmers growing tomatoes in the Northeast, and they still need good varieties, right? So that's kind of what I see as my mission as a public sector breeder working for Land Grant University in New York. Try to focus on those areas that aren't necessarily like the areas of emphasis of the company, select for those traits, and then get that material out into the world, hopefully, and into the hands of farmers, ideally. So that's like the main motivation. What that means in terms of what we select for, I mentioned disease resistance. So in the Northeast, the like suite of diseases that people might expect to find on their farms is different than what that looks like in Florida. There's some overlap. There's some diseases that you expect in both places, but there's some that you expect more of in New York or less of, right? So we try to focus on those diseases. We try to focus on quality, flavor, and appearance, right? I think that's especially important with a lot of farmers in the Northeast. Many people who maybe are selling directly to consumers through markets or roadside stands or CSAs. But, my experience talking to vegetable growers, even people who are selling wholesale, quality is always important, right? Product has to look and taste good. Ability to thrive in unpredictable seasons, I guess you could say, right? I mean, sometimes we have flooding and drought in the same year. Tomatoes are very susceptible to fluctuations in water availability with issues like cracking or blossom end rot. So we try to select for those types of traits as well.
Very cool. That's a really cool thing that I think Cornell has some other similar programs like that. Like, I think there was a Northeast broccoli project that was doing a similar kind of thing. Like I know just from working in the industry, like you said, seed companies tend to breed for their biggest customer. And so like, actually, at the beginning, I worked on broccoli for a little while at Johnny's, and I learned that most of the broccoli is bred for coastal California because
Exactly.
that's where most of the broccoli is bred, or that's where most of the broccoli in this country is grown. And so like I felt like my job was trialing varieties that were bred for coastal California to find out which ones work in the Northeast or Mid-Atlantic or, yeah. And in fact, a couple years back, we had Jan Vanderheide from Bejo, who used to be at Bejo Seeds. So he's retired now. Okay, I was wondering if you might know him, and he was on and he talked about his work. I don't know if Bejo was the only collaborator on that, but there's if people don't know, there's a Dutch seed company called Bejo Seeds that I think was one of Cornell's cooperators in the Northeast broccoli project. So that's really cool. I didn't realize that you were taking sort of like a similar approach to the breeding up here in the Northeast, but that's so important. Like, if I can just digress for a minute, I feel like my guess is that's part of the reason there are so many seed companies up here in the Northeast, because right. I think the Northeast was kind of abandoned. Like seed companies serve, as you know, most of them are national or international. We're like, well, there's this like cold part of the northeastern United States, southeastern Canada, like, they weren't really developing varieties for this region of the country. And so, to my mind, I could be wrong, tell me, but I feel like that's part of the reason we have Johnny's, High Mowing, Fedco, there's also Pine Tree Garden Seeds up here. I think they kind of created a vacuum by sort of like walking away from the Northeast, into Definitely. Which, all those companies and, Cornell doing important work in this area, because like one thing about local growing, right? Growing for market, most of our growers are selling locally or, perhaps wholesaling regionally or something like that. But, most of our listeners are not shipping coast to coast.
Right.
And so
exactly.
the reality of that is that most growers are not growing their crop in the like ideal place to grow it, right? Because the industry has realized that the ideal place to grow lettuce, for example, is like the Salinas Valley in the summertime and in like Arizona, maybe like Yuma, Arizona, to be really specific, in the wintertime. That's why I don't know, like 90% of the lettuce in the United States is produced in those places. But of course, then we have to have varieties for the local growers who are wherever they are and, aren't in the like greatest place for growing lettuce or tomatoes or any of these things. So I'm so glad that you're doing this work to develop varieties that are, have regional adaptations outside of the big, obviously California and Florida would be the two biggest. So glad you're working on that for growers, because obviously they need varieties that are going to be adaptable, like you said, and work in variety of weather conditions, a variety of places, not just, but including California and Florida.
Yeah, exactly. That's what motivates us. And yeah, I mean, it's, you mentioned that the industry decided that the best place to grow lettuce in the summertime is Salinas, right? But it doesn't mean that you can't grow really excellent quality lettuce in Pennsylvania or, wherever else it might be. But unfortunately, growers in Pennsylvania don't have access to as much investment in R&D and varieties that are suited to that environment compared to growers in Salinas, right?
Yeah, absolutely. Okay, so I'm curious. There's a variety called chocolate stripes. I wonder if you know it. I'm just going to say, if I really like that variety, I think it would be prime for some Hylooming. If you ever, I don't know if you're familiar with that variety, but that's my suggestion for you if you haven't tried it.
Is that a small stripe, like a cherry or cocktail size, or?
Oh, good question. So what I heard about this variety, it's a beefsteak. So it's a brownish beefsteak with stripes. And so I could find out who, but what I was told is that it used to be like a really smaller variety, like kind of like commercially too small to be a beefsteak. But there's some grower in California who liked it a lot and just worked on it himself, I think on his own farm, of just every year selecting the biggest fruits. Okay. And over time, it's now a proper beefsteak. Like you can buy it's in some seed catalogs. And I like that one a lot just because it's beautiful in the way that the black tomatoes are beautiful and interesting, that has the striping, and also had really good flavor. So it would be, but it would be an indeterminate beefsteak that you could work on if you want to. It's
good to know. Like I cannot keep on top of all of the tomato varieties that are out there. One thing that's interesting with tomatoes, especially, but this is the case with lots of vegetable crops, is that in addition to the big seed companies, there's also many independent breeders who are breeding in some cases in their backyard or on their farm or in collaboration with other people, and they're selecting really fantastic varieties that are coming onto the market too, which makes it an exciting crop to work in, but it's also kind of daunting. There's so many varieties out there.
Yeah, that's why I said, like, I realized, like, me telling you one more variety, like, you probably get variety suggestions from people all the time. You're probably like, I'll put it at number 999 on the list. But if you ever find yourself wanting for varieties, that's one that I liked a lot, that I think would make a really nice Hyloom, is chocolate stripes. But
we'll check it out.
Hey, can you tell us what your year looks like as a plant breeder? I'm assuming that it's seasonal, kind of like farming, but maybe I'm wrong about that.
It is seasonal, but we are busy year round, although we're more busy in the growing season than in the off season. So maybe I'll kind of give you a picture of what like the start of like variety development looks like, to give you a sense of like the life cycle. So we do all of our cross pollination in the greenhouse at Cornell, and we do that in the fall. So we will sow that seed maybe the last week of September or the first week of October. Hopefully by the end of the year, the plants are flowering and we're making crosses. And then we try to harvest that seed in January and sow the next generation, the F1 seed, put that in the greenhouse in the spring, get that to self-pollinate. And then in that summer, the first summer after the cross, we have what's called an F2 population. And this is the generation in which you see all of the segregation for all the traits that are different between the two parents. So if I cross something that's red and determinate and late blight resistant with Brandywine, for example, an indeterminate pink variety, in the F2, I'll see combinations of all of those traits. So I'll see, determinate plants that are pink and late blight resistant, right? And then we'll select the plants with the combinations of those traits. And then the process continues. We keep selecting until we we call it purifying the lines. We inbreed them until they are stable and come true or reproduce the same phenotype year after year. I'm getting a little bit too much into the details of the breeding process instead of kind of sharing what the seasons look like. But to summarize, in the winter, we're in the greenhouses, we're making crosses or advancing generations or analyzing data. And then in the summers, when we put a lot of plants out in the field and we're evaluating them, making selections, collecting data, and planning what's going to move forward in the breeding program. Our busiest seasons, I would say, are right now, like April, May, June, which is when we make all the plans for the field, package all the seeds, sow all the seed, transplant it. Then there's a little bit of a lull in the summer. There's still a lot of work to do. We trellis a lot of our fields, and we grow about 4 acres every year between tomato and eggplant, but it's mostly tomato. So there's a lot of work to take care of the plants. And then starting in August, September, October, that's also a very busy season for us as we're collecting data on the fruit characteristics. We're making selections, and then we're extracting seed out of the selections that we're making.
All right, so you make these crosses, basically grow them out, and then like take data and presumably taste them. And then you like take seeds from the ones that are interesting to you. I mean, is that the right summary?
Yeah, exactly. It all depends on what the cross is and what the goal of the cross is and how it's going to be used in the breeding program, right? So, maybe we have one parent that has really excellent quality, really good flavor, and then we cross it with something else that's disease resistant. So in that first generation, the F2 generation, we might advance the plants that we can easily see have the disease resistance. And then in the later generation, we might try to select for the flavor, taste the selections that made to that point, see which taste the best, and then advance those, right? It's tough to select for everything in every generation necessarily. But yeah, that's essentially how it works. And then when we have inbred lines, those can be shared with companies, or we can make our own hybrids ourselves by crossing those to each other and looking at what the F1 hybrid between them looks like in the field.
Okay, cool. And so just to circle back on something that you said, as you pointed out, you make a cross in the greenhouse, and that the seed that comes from that cross is the F1 generation. And then the seeds from the next generation are F2. And because I just wanted to mention for people, if they never got that, like why they see F1 by, it's called an F1 hybrid in the seed company. Is that for first filial? Am I wrong? F1 is first filial, or is it?
That's what it stands for, which is kind of a weird esoteric term that plant breeders chose to use at some point. But I guess I'll just backtrack a little bit and talk about the difference between an open pollinated and an F1 variety.
Yeah, that'd be great.
And then also what an F1 means in terms of the breeding process. So an open pollinated variety breeds true. If you save seed from it, you'll get something that should look the same as the previous generation the following year. In the case of tomato, which is a self-pollinating crop, it means that the plants are inbred. There's basically no genetic variation within the variety. So you won't see any genetic variation the next year. An F1 hybrid is a specific type of variety that plant breeders have been making in different crops since the early 1900s. It started in corn. And that was because plant breeders realized that if you cross 2 different parental lines together, you can get the F1 generation, the cross between the two, that shows what's called hybrid vigor, or better performance than either of the parents. And they really took advantage of that, and the F1 hybrid seed industry took off in corn and then spread to all sorts of other crops. Today, F1 hybrids are commercialized and released for a variety of reasons. It's not only that hybrid vigor phenomenon. There's a few different reasons why a plant breeder or a seed company might choose to release an F1 hybrid. The first one, the most important one, is that reason exactly, right? You can get this hybrid vigor in the F1. It can also make the plant breeding process easier to release F1. So an example is disease resistance. Maybe I want my variety to have 6 different disease resistance genes. If I want to cross all of those into one variety, that's going to be pretty difficult to do. It's going to take me a while. However, most disease resistances are dominant. So if you make a cross between 2 varieties and one of them has the disease resistance, the F1 will also have the disease resistance. So I can also cross something with 3 disease resistance genes and something else with 3 different disease resistance genes. And then in the hybrid, in the F1, it's expressing all 6 of those. I didn't have to put all 6 of them into one single plant, right? Well, I mean, they are, I guess you could say, but not one single line. I crossed 2 different parental lines and got all 6 together. And then the last reason is not really a biological reason, but it's more for intellectual property protection. And that's the fact that the F1 hybrid doesn't breed true. And if you save seed from an F1 hybrid, you get an F2 generation, you get the segregation of all of these traits that are different between the parents. So that what that means is that if I'm a company and I spend 10 years developing a new variety and it's open pollinated, it's not an F1 hybrid, if I don't get some type of patent protection, like a plant variety patent on it, and I release it out there, another company could just buy that seed, grow it, harvest the seed, and then sell it the next year, right? They're perfectly allowed to do that. And it would be the exact same seed as the variety, the exact same genetics as the variety I developed because it's open pollinated. Most companies in that case would, get some kind of patent to protect their variety. But an F1 hybrid is like a built-in patent almost because it doesn't breed true. You can't just harvest the seed of it and then have the same variety. It's impossible to recreate that without having access to the seed of the parental lines. So releasing varieties as F1 hybrids is also kind of a way for companies to protect that variety as almost like a trade secret.
Yes. Because a lot of work goes into them. Like you mentioned, it can take a long time. Like one number that I often hear thrown about as far as developing a stable open pollinated variety is that it takes about 7 generations of, like, once you make the first cross, the F1 generation, it's like you have to get to a F7 generation a lot of times. And I know it's not a perfect formula. Like sometimes varieties stabilize more quickly, and maybe some take longer. But I guess I did want to ask if that's in the right ballpark to say, like you said, if a company to develop an open pollinated variety, it probably is going to take them 7 years or like 7 cycles, because a lot of companies are doing like what you guys are, where they might have a generation in the field, they might have a generation in a greenhouse. I mean, I know some companies get as many as like three cycles in a year by going like different continents, multiple greenhouses or different continents. There's a lot of ways to speed up that cycle, but essentially that to put 7, is that pretty accurate to say that a company would probably put 7 years of research or 7 breeding cycles to get an open pollinated stabilized after the F1, the initial hybrid cross that would lead to an open pollinated variety?
Definitely. The rule of thumb in breeding is that the amount of variation in the variety or the amount of heterozygosity decreases by half each year.
Oh, okay. I've never heard that before. Cool.
So in each generation. So in the F1, if you think about traits that are different between the parents, F1 is 100% heterozygous for all of those traits. It has 1 copy from parent A and 1 copy from parent B. And then if you self-pollinate the F1 and look at an F2 plant, that's now 50%. So for 50% of those traits, it now has 2 copies of the same gene that came from one of the parents. And 50% are heterozygous, so it has 1 copy from one parent, 1 copy from another parent. In the F3, that's 75%. In the F4, 88%. In the F5, 94%, and so on. So that's why it takes till the F7 to get close to 100%, what we call fixed or inbred.
Oh, cool. Okay, thanks. I never heard it explained like that. That's very useful. And now let's take a minute to hear from our sponsors. It's with their generous support that we can bring you the podcast for free. Farming is hard. Running it shouldn't be. Tend helps you plan your season, map your farm, and track every task from seed to sale. No spreadsheets, no guesswork, just seamless workflows. Tend is the all-in-one farm management platform that brings together planning, field mapping, fulfillment, real-time inventory, sales, labor, traceability, and accounting in one easy platform. Built for small market gardens, CSAs, and large diversified farms. Get started with a free account at tend.com. That's TEND.com. No credit card required. If you grow for market, you know performance is everything. That's why so many farmers are turning to Burpee's Farmers Market. Dedicated to professional growers, Burpee is now offering non-GMO seeds in larger quantities, bred and selected for standout flavor, strong yields, and the kind of visual appeal your customers crave. All farmers market varieties are trialed at Burpee's research farm in Doylestown, Pennsylvania, where expert horticulturalists test for germination rate, vigor, disease resistance, high yield, and consistency. Things that make a difference in the field and to your bottom line. The seed assortment includes USDA certified organic varieties, Burpee bred classics, heirlooms, and exciting new introductions. Burpee's been doing this for 150 years, and they're still creating new varieties with growers like you in mind. You can check out the full lineup at burpee.com/farmersmarket. That's burpee.com/farmersmarket. And now back to the show. All right, I have two quick comments on what you just said. First of all, I do want to say for our audience, partially because I feel like there's a lot of confusion about like what's natural or not natural or genetic modification or anything like that. It's like hybrids have also been happening since forever. A hybrid happens when a bee goes to one squash, gets some pollen on it, and then goes to another squash. So it's not, this is not something unnatural. It happens by insects, it happens by wind and all those kinds of things. So I just want to drive the point home here for people that we are talking, this would be considered classical or like natural plant breeding here. It's just taking pollen from one plant to another. This is not genetic modification or anything like that.
Yes, exactly. The F1 hybrids don't necessarily have anything to do with genetic modification or bioengineering, although in some crops you might have F1 hybrids that are GMO, right? Especially for crops like corn or crops where GMO is common. In tomato, as far as I know, there's only one variety on the market that's a genetically modified organism that has a gene from another distantly related species, and that's the purple tomato. I don't know if you've seen it, but it's a company, I think they're called Norfolk Healthy Produce. They took a gene from snapdragon flowers that produces anthocyanin, or a purple compound, and they used bioengineering to move that into tomato, and then they have varieties that are like bright purple, like a blueberry. So if your tomato is not like bright purple, and I'm not talking about like Cherokee purple, which is a different type of purple, your tomato is not GMO. But yes.
Right. Okay. Yeah, there was a bit of controversy about that because I seem to remember that tomato being released, and some of the seed companies were saying that it was from natural breeding, and then it turned out it was not entirely natural.
That's correct. Somehow some seed, I don't know if it was like before it got released or something, but somehow some seed of that got out into the world and made it out into some seed catalogs that were theoretically only selling like open pollinated heirloom varieties. And I guess that they thought that it was some like naturally occurring thing in tomato, but it wasn't. It was this bioengineered trait that made it out there. And I think once they realized, they corrected their mistake there. But yes, if there was a brief period of time when it was being like sold by some seed companies as an heirloom variety.
Yeah, I mean, I don't know if it's too much to get into, but there's not a lot of genetically modified tomatoes out there. I mean, I think one thing, they're very expensive to both develop and release. And so that's like, yes, there's a lot of genetically modified corn, soy, I think like cotton, papaya, I don't know how much of the papaya, but you know what I mean? Like there's certain crops where the economics of that work out, to my understanding. Yeah, there's that purple tomato. There's the flavor saver. Do you know what I mean? Like there was the tomato that I think they put a fish gene or something into to make it, I think it was for shelf life, and that didn't take off. So it's, the vast majority of, other than those examples that you mentioned and that I'm aware of, it's like the vast majority of tomatoes on the market are traditional breeding. So
exactly.
Okay. And I also did want to like double down on what you said as far as there's reasons why, in addition to and beyond intellectual property, that people would release a hybrid. And for example, like we were talking about what a big problem late blight was. Well, all the first late blight resistant tomatoes that got released commercially that people may have grown were hybrids, right? Because they could more quickly find a tomato that had late blight resistance, breed it with a tomato that had good eating qualities or whatever the other goals were. Like you said, like combine the characteristics of the one parent with the other parent. And so they were fairly quickly, because I think companies, including Johnny's that I was working at the time, released some late blight resistant field tomatoes within a year or two of that event in 2009 that wiped us out up here in the Northeast, because they were able to make hybrids instead of waiting those seven cycles to stabilize and open pollinate it. So like that's a really good example where hybridity actually was a good thing if you're struggling with late blight, because it means that they were able to bring a commercial variety to market more quickly because they were able to release a hybrid variety and not have to wait around all those extra breeding cycles to make an OP.
Right.
But one thing I just want to mention, another thing about tomatoes is just that tomatoes oftentimes do just breed true when left to their own devices. And tell me if I'm wrong about this, but because tomatoes have perfect flowers, right? And that they have the male and the female parts on the same flower. What I've been told is oftentimes tomatoes are pollinated by the time like the flower is fully open. So that's one reason why people can, like if people are growing a few different heirlooms, oftentimes people will have success saving seeds from heirlooms, even if they were growing other heirlooms, because tomatoes are inbreeders. They tend to inbreed, and that's something people can look into. There's a lot of crops are divided into either inbreeders or outbreeders, like squash being a good example, if I'm remembering correctly, of outbreeders, right? Is their flowers are not perfect. They have separate male and female flowers, and so they can self-pollinate. If a bumblebee goes from they can pollinate as far as the same plant. The same fruit can't pollinate itself, right? Because like a bumblebee could go from, let's say, a male flower on a squash plant and go to a female flower on the same plant. And you could essentially have a self cross that way, but not in the same way that a tomato would have a self cross with the pollen from the same fruit going to the ovary of the same fruit. Did I butcher that? I haven't studied breeding as much as you have.
You're exactly right. Yeah, tomatoes tend to self-pollinate. If you look at a tomato flower like very closely and like dissect it, you'll see that the anthers, which are the organs that produce the pollen, actually form a cone. And the pistil, which is the organ where the pollen lands at the tip of the pistil, the stigma, germinates and then fertilizes the ovules in the ovary that then becomes the fruit, that's contained entirely within that cone. So the pollen basically falls off of the anthers onto the pistil of that same flower. So for most tomato varieties, if you plant two varieties right next to each other, two heirloom varieties or open pollinated varieties, you can harvest seed off of one of them, and 99% or more of that seed is going to breed true to the variety that it came from. There are other cases, like you said, with like squash or corn, where the plants tend to cross-pollinate. They tend to outcross. And in that case, if you want to preserve the seed of an open-pollinated variety, you need to plant it in isolation from other varieties, because otherwise that pollen's going to mix between the two varieties.
Okay, thank you. All right, well, since we're talking about genetics, I watched a YouTube video of a talk you gave in 2024, and in it, you said that one of the goals of your breeding program was to discover the genetic basis of agronomic / consumer importance. And as far as agronomic importance, I assume you mean that it grows well for the farmer. And as far as consumer importance, I assume you mean that it tastes good and perhaps also looks good for the consumer. Am I right about that? Is there anything you want to add to that?
Yeah, I guess maybe that was just a overly complicated way of saying that, we study the genetics of traits that are important to whoever's eating the tomato, right? Especially in terms of flavor, or whoever's growing the tomato in terms of things like disease resistance or resistance to abiotic stresses. And then, in terms of the characterizing the genetic basis of these traits, in many cases, that's trying to find maybe not the exact gene that confers the trait, which often is very difficult and can take many years, but at least the location in the genome where that gene is. And if we know the location, then we can develop what are called molecular markers or DNA markers that can predict that trait. And then that can be used in breeding to make the process much easier, right? Instead of putting our plants in the field and hoping we get late blight or spraying the plants with late blight spores, we can just run a DNA test on the plants and see which ones are carrying that late blight gene and select those.
Yeah. Okay. Because that's kind of what I was getting at, is like, I was curious about if you could find, like, if there are markers for like the disease resistances, like if you're able to say, like, find, like, oh, let's say early blight resistance, like, lives here in the genetic code. And so, because that was my understanding, is that breeders were able to, like, part of the work was figuring out which gene or genes correspond to, like, a desirable agronomic or consumer trait, right? So, like, basically, like, this gene correlates to early blight resistance or something like that. So you can you can basically, that was my understanding, is that just like in people, they're trying to find genetic markers for, like, all kinds of diseases and things, right? So they can just tell you of, like, if you're at risk for a certain thing. Once again, there's, no genetic modification or any here. It's just basically wanting to look at basically understand how a person or an organism's genes correspond to, phenotype, or basically, like, the traits that organism has in the world. And so, because, yes, like, classically, I understand that plant breeders, if they were breeding for, like late blight resistance, they would have to plant a whole bunch of plants out in the field, hope they get late blight, or heaven forbid, put spores on them and release into the environment. Whereas, I mean, I assume that's probably speeding up the development process on plants to be able to find markers. And so, is that something you're doing, or is that another process? Is that like another lab that is trying to look at the genetic code of, say, like, tomatoes and figure out which genes correspond to which traits?
We do that too. That's part of our research mission. We don't get into the details of, like, exactly how the gene works and what's happening at the molecular level. There are more, I guess you could say, fundamental scientists who study those elements. We try to focus on the more applied side, and that's what markers can predict the traits and how well do they work, right? And then how can we use those in breeding? And traditionally, a lot of this work has happened at universities. They've discovered genes that confer traits in tomatoes and many other crops. And then seed companies have been able to use molecular markers to easily select for those traits. Then that information goes out into the world and becomes something that's used by a broader community and makes it easier to select for that trait. And nowadays, there are companies that are like DNA testing companies for vegetable crops, right? Just like, there was 23andMe for humans, and you could test markers and see if you have certain markers that are associated with susceptibility to certain diseases. There are companies that will do that for, like we said, late blight resistance or resistance to all sorts of other diseases in tomato. You can just send them a little piece of leaf tissue, and then they'll send you back the answer on whether it has that marker or not. And they're able to do that because they're using information that different university labs have discovered over many, many, many years and published as to where those genes reside in the tomato genome.
Okay, cool. Because I was thinking about that when you were saying how daunting it must be in a way to know that, like, so many people love tomatoes and, breed tomatoes, like, as a side project, or there's kind of a lot of competition in a way. On the other hand, I figure most of the farmers and backyard breeders are probably just taking two varieties that they like and crossing them. Whereas you, with your lab and everything, do have a certain advantage as far as, obviously, you have the training and understanding at the genetic level to do that work. And also you're used to taking a leaf sample and sending it off. Although that's a really good point you make, that there are labs that will do that for people for a fee. And so, that's a really interesting idea, like, which should speed up anyone who wants to do that. It could speed up their breeding project. Like, let's say a backyard breeder took chocolate stripes and crossed it with some late blight Iron Lady. I don't know. Yeah, Iron Lady has late. Yeah. Okay. So let's say somebody crossed chocolate stripes with Iron Lady, and then they have 10 plants that they like a lot. They could take leaf samples from those 10 plants, send it off to a lab, and find out which one of them have that gene for late blight.
Exactly.
Okay. So, that's actually, I'm glad you brought that up, because that's a way that anybody really could harness some pretty advanced, scientific techniques to both speed up their breeding program and confirm it. right? Because what if you thought your plant had late blight resistance because it didn't get it in a particular year, and it turns out just didn't get it. Yeah. So it's like, it's good to know, like, this is a good thing for everybody to know, like, on a genetic level, like, yes, this really has the resistance. It's really not going to get like late blight.
Yeah, I think it's a fantastic thing for the companies like this, these service providers, to exist, because in a way it kind of like democratizes the breeding process, because you don't need to be part of a huge multinational seed company in order to have the resources or the know-how to do these things like run genetic markers. You can just send a piece of leaf to another company that does have that expertise, and they'll give you the results, right? And I think in recent years, especially, there's been an increase in the number of independent breeders and smaller seed companies, and they're able to develop varieties that are just as good and can compete with these, with large multinational seed companies. So yeah, the breeding like ecosystem is an interesting one, and I think everyone kind of has their part to play, right? The universities, the huge companies, the smaller companies. There's a lot of movement of information between these different players, and at the end of the day, I think everyone kind of benefits because it helps good varieties get to the hands of farmers.
I think you're right. Yeah, it's a good thing for everybody. Hey, okay, so we were just talking about developing genetic markers, and I assume that's pretty useful for most, if not all, of the disease resistances. Like, I would assume that that's something that, I don't know, want to use the word easy, but can have a genetic marker. Where I'm going with this is, so I've got my list here of all the like defects that you evaluated for, which is also like anybody who's grown tomatoes in general, heirlooms especially, will be familiar with these. Like, you evaluated against blossom end rot, zippering, catfacing, yellow shoulder, radial cracking, concentric cracking, and large stem scar. So I'm guessing those seem like traits that are complexly inherited, if that's the right term, and I'm guessing there's not a gene for zippering or not zippering, but I don't know. Am I wrong? Like, am I right? Are those sort of like defects that cause a lot of the seconds in tomatoes and heirlooms especially, are those things that you can find a genetic marker for, or are those all complex traits that have to do with susceptibility, but also like growing conditions and all that kind of stuff?
Yeah, that's a good question. And the answer is a little bit of both, although more the latter, more very complex and dependent on the environment. But there are a few cases where there's like a single gene that, has a strong influence on these traits. And oftentimes they're genes that were intentionally selected for in heirloom varieties. So as an example, there's a gene called fasciated, which basically results in many of the flowers being large and kind of fused together. And that leads to these big ribbed fruit that you see in a lot of heirloom varieties. And that is also associated with a really high degree of catfacing. So, it leads to the distinctive appearance of the variety, but it also causes a lot of the deformed blossom end that can be so bad that it, can prevent that fruit from being marketable. Another example is pink tomatoes. So varieties that are pink, like Brandywine, for example, they have what's called clear skin. So if you were to like peel back the skin of the fruit of Brandywine compared to a red tomato, you'd see that the Brandywine skin is clear, whereas the red tomato skin is actually like yellow. And that's what results in that difference between the pink versus the red fruit. And that clear skin is also associated with a higher amount of cracking. Something about the skin itself, I don't know if it's thinner or something, but if you have a variety that's pink, it's more prone to cracking than other varieties. So there's trade-offs, right? And like trying to select for all these things. But in most cases, like you said, these are really complex things, and there's probably many, many genes that are involved in sensitivity to these defects, and then they're also really, really dependent on the environmental conditions.
Okay, that's very interesting. I didn't know that either of those traits had a genetic basis. I'm definitely familiar with the defects that they cause, but that's why I asked, because that's very interesting. So in your breeding program, are you looking for those markers for those things? Or are you, particularly for the defects that cause seconds, or are you just like taking notes, like in the field of like, this one has a lot of catfacing, probably not the best candidate or whatever?
Yeah, it's all by visual evaluation. We're trying to get to the point where we can select for these things with markers, but I don't think we're we have that sophistication in our program yet where we can do that because of how complex the traits are. For things like these disease resistances, we do use markers to both select and to, like you said, confirm the presence of these disease resistance genes. And then for these other traits, like these really complex traits, what the flavor is like, how productive are they? What's the yield? What proportion of the fruit are marketable and free of catfacing and cracking, et cetera? That all comes from us, growing the plants and evaluating them and collecting that data, or in some cases, just looking at them visually and discarding the ones we don't like.
Okay, just got to do some good old-fashioned eating tomatoes to find out some.
I'm someone who loves tomatoes. But even so, like we go through so many in August and September that I get to the point where I really don't want to like see another one for a few days. I never thought I would get to that point in my life. I'm such a big fan of tomatoes, but when you spend all day just walking a field and slicing and tasting hundreds of tomatoes, it can get tough.
Oh yeah, the struggle is real, Greg. I feel your pain. I love tomatoes, and doing the trialing at Johnny's brought me to the same point. In fact, I mean, like, kind of a funny story is that when there actually were when I got hired as a technician who did tomatoes and some other things at Johnny's, there were actually 2 positions open. And so there was a range of crops, and I really wanted tomatoes. And luckily, the other person who was in contention for the job did not like fresh eating tomatoes. Okay. And so they got a job too. They just got different crops. And so then you can imagine, like, if I had these trials with 200 or 300 tomatoes in the field and then another 40 or 50 in a greenhouse, by the end of the season, I was ready to take a break from tomatoes for a while. I mean, I would try to pace myself. I'm sure you do the same, or if you have all the different types. So, of course, the smaller fruited ones start ripening first. So I would just try to like get started in on the small fruited varieties early in the season. And so it's not like eating, because obviously there's only so many tomatoes you can eat in a day after your taste buds kind of like go numb. So that's how I handled it. I tried to just like start on the smaller ones as they started ripening and make my way through the trial so that I was never in that position of needing to I've got to try 50 varieties today before it freezes. But yeah, it can be a bit much, especially considering not all the varieties tasted that great. So exactly. I used to tell people part of my job is eating bad tasting tomatoes to find out which ones actually taste good.
You're right. That is what makes it tough. And we find that. I mean, a lot of our crosses, a lot of the offspring that we're looking at do not taste good. But we don't know that when we, cut a slice out of them and take a bite. So that makes it especially difficult. But it also gives me more appreciation for the ones that do taste really good.
Yeah. Yeah. And you're really happy when you find a really good one. Okay, I wanted to loop back on the defects real quick, and because there's a few things that I've been told about some of these defects, and I don't know for sure if some of it's true. And I'm curious to get your take on it. Like, okay, so blossom end rot, for example. Blossom end rot, I know, drives people crazy sometimes because, I mean, blossom end rot technically is that there's not enough calcium getting out to the end of the fruit. And so it develops like this necrotic or dead tissue. But I know there's a lot of other complex interplay of like, if there's been like weather variability, like you were talking about, like I think people can get blossom end rot either when there's been a flood and the roots aren't taking up calcium, or conversely, when it's been too dry and the roots aren't taking up calcium. And then there's a certain susceptibility aspect. Like I know usually the longer tomatoes, like paste tomatoes and San Marzanos and stuff like that are more susceptible to blossom end rot. So am I right that in blossom end rot, it is like just seeing how they do out in the field, and you'll notice certain tomatoes are more susceptible to blossom end rot than the others? Or is there a blossom end rot gene?
No, there's not, as far as I know. But like you said, there is like variation for degree of susceptibility. Yeah, I've heard a few people say that plum types or Roma types are more sensitive to blossom end rot. I wonder if it's like the shape themselves, or if those are varieties that tend to have a really concentrated fruit set and are putting on a lot of fruit at one time. And that, I think that can also be correlated with blossom end rot susceptibility. But like you said, it's caused by a calcium deficiency in the fruit tissue where the blossom end rot develops. But the reason that there's a calcium deficiency is typically because of some issue with the movement of calcium through the plant that's related to water transport. So inconsistent watering, basically, periods of dryness or periods of excessive watering are known to kind of trigger blossom end rot. But yeah, it's really tough. I think in the field we generally see it in that first flush of fruit, especially the earliest fruit that's set.
Yeah. Okay. Yeah. Well, that's what I had been told, is that the long fruited tomatoes are more susceptible. And I feel like anecdotally, I've noticed that, like, we don't usually grow San Marzano types in the greenhouse, but in particular, one year we did. I can't remember why, because they're not usually as in high demand, or people aren't usually willing to pay as high of a price. For some reason, one year we threw a row of San Marzanos in the greenhouse, and they definitely had worse blossom end rot than the ones around them. So once again, it's anecdotal, but I mean, that's something I'd always been told that jives with what I've seen in the field. So
makes sense, I guess. I mean, if you consider like the distance from the stem to the end of the fruit, I don't know if this is a gross like oversimplification, but it's a greater distance that calcium would have to travel, right?
That's what I've been told. And so that's one of those things like I hate to repeat in a way, because I'm not 100% sure, but and I don't know if that's somebody like making sense of what they've seen. Like, I believe it. I feel like I've seen a lot of blossom end rot in long types. I've been told that it's just because the calcium has a longer way to get out to the tip. But whatever the case is, it fits with what I've seen. And I don't know if that's somebody just making an explanation or to fit.
Well, you've convinced me. So.
Okay, and so two that I wanted to talk about together were zippering and catfacing, because I've also been told that not only are heirlooms more susceptible to like pretty much all those defects, mainly because my understanding is that the greenhouse types have been bred not to do that, right? Like not producing seconds or damaged or seconds fruit, however you want to put it, is a high goal. So if you think supposedly all the heirlooms that we have have been, the way they are for a long time and haven't had any breeding work done with them, it goes to make sense that they would have more defects than varieties that have had breeding work done on them. Presumably one of the things that people would be selecting against is seconds fruit. So I do believe that the heirlooms have a higher propensity for seconds, for all the seconds that you mentioned in your trial. And yet the other thing about zippering and catfacing in particular is that I was told that both of those are worse, not only in heirlooms, but also in tomatoes when it's too cold, when that flower is developing. And that's something that seems to jive based on, once again, on my anecdotal noticing, just because we grew tomatoes in an unheated hoop house here for many, many years. And so, in Maine, we have short season, cold nights. And so, because what I was told is that zippering and catfacing, sometimes as you describe, of like those big, huge tomatoes, are both because of deformities, or that what I was told is that when the tomato flowers are too cold, and I want to say like 50s and below, or roughly, basically like the temperature that it won't kill a tomato, but it's not very happy at. I was told that when tomatoes are developing with cold nights like that, they don't always separate properly. Then when the flowers are forming, like when you can't even see them, like if you think about it, whenever you transplant a tomato out into your like hoop house, let's say, there are probably flowers forming, even if you can't see them, they're forming at a microscopic level. And so I was told that the zippering is part of and we should, am I right? Zippering is like, it looks like a zipper, that it's just like a weird mark that goes down the side of the fruit. And so I was told that zippering is one thing where the tomato flowers aren't really forming, like they're in conditions that are colder than they really want to be, and the flowers are kind of like sticking together a little bit, because that's kind of what the zipper looks like. And the other thing with that catfacing is that those huge tomatoes, like you mentioned, that oftentimes are cat-faced. And so, by cat-facing, we mean defects on the blossom end. Like, you tell, like, if you can put a finer point on any of this, or can give a better definition or elaborate, please do. But, like a lot of people know what catfacing is, but in case people don't, I mean, the defects on the blossom end of the fruit that do kind of like, sometimes they kind of do look like the like ears and eyes of a cat. But one of the things that makes that especially bad is when you get two tomato fruit that are fused together, which goes along with the problems with tomato formation when it's too cold, because one thing that I think people can do is they can look at like those huge tomatoes that heirlooms are prone to throwing off to producing. Well, tomatoes usually have 5 sepals, right? It's like the little, people don't know, like the stem of the tomato usually has 5 little sepals, 5 little things. Like the normal number for a tomato where it connects to the plant is to have 5 little sepals, which were like around the flower before the flower opened. And if you're looking at that tomato and it has more than that, like I think there can occasionally be a little bit of variation, but if you're looking at your tomato and it has like 10 sepals or like 8, that's probably because that one fruit is really more like a compound fruit, right? It's like two fruit that never, and this, I'm curious, like both if there's a genetic basis or if you've heard the same thing about one of the reasons that you get those huge fruits, like we sometimes call them king fruits, is because that was supposed to be 2 fruits and that they're like a conjoined twin of tomatoes. And that's why, and also like people call them boat-shaped fruit instead of, I think that's why tomatoes get, instead of being round, it's like when you get 2 fruits fused together, they make this kind of like oval boat-shaped fruit instead of a round fruit, because it's what it is it's actually 2 tomatoes fused together. And so I guess my question is, does that jive with what you've heard, that not only are heirlooms more susceptible to all these kind of defects, but those defects are even worse when the flowers are forming at particularly cold times of year? And because I'll say, I've noticed, I feel like we have more seconds due to like zippering and catfacing at the beginning of the season, like which is really demoralizing too, right? Because those are your first fruits. You're like, you want to sell them, and then there's lots of problems with them. I feel like, I guess that's why I'm asking, because that's one of those things that I've been told it jives with my experience in the field. But I was wondering if you knew anything about that, if it's just like heirlooms are more susceptible to this, or if you think that could also have to do with the flowers forming in conditions that are colder than ideal.
What you've described is what I've understood as well. I'm not by any means an expert in like the physiology of these disorders. But yeah, it's all related to the flower and what happens when that flower is pollinated and the fruit begins to set. Zippering, I think, is caused by when one of those anthers like sticks to the ovary or the fruit as it begins to develop. Yeah, catfacing, I don't really know exactly what causes it, but yeah, like you said, it tends to be much worse in fruit that develop from fused flowers. Zippering is something that to me is like really just cosmetic. Like it doesn't really detract from your ability to enjoy that tomato. Catfacing can be so bad where you can't even like really get a good slice out of the tomato because so much of it is taken up by that deformed blossom end that kind of grows into the fruit. We do trials of like standard commercial, red slicers as well. We don't really see much or any catfacing at all in those varieties, but we do see zippering in those varieties as well. And blossom end rot we see, across the board.
Okay, well that's a really good point. Is depending on what people's standards are for firsts versus seconds. Yeah, zippering might be okay. I mean, like also depends. Sometimes I don't know. People may be wholesaling. If like wholesalers might not want zippering. Because like you said, yeah, it's zippering is usually more of a cosmetic thing. Although I think we would, if a fruit was perfect other than having a zipper on it, we probably would have sold it, for a number one price at a farmer's market. You're right, since it doesn't impact the eating quality. Although, like you said, yeah, that's one thing I don't like about cat-faced fruit is that a lot of times there's so much, it's like there's almost like stem material, and there's a lot of connective tissue or stem material or something in the tomato that's sometimes isn't good to eat, and it can be hard to tell whether there's a lot of that. Like on a cat-faced fruit, it can be hard to tell if there's a lot of that connective tissue in there or not without cutting it open, right? So it's like not really something that we wanted to sell to a customer just because they might or might not have a bad experience with the fruit. So, So, I mean, some of this stuff definitely, like, I don't know. So I know it's always frustrating to farmers to have to consider something a second because of cosmetic reasons. But that's one I feel like the catfacing could sometimes actually impact how much somebody could really enjoy that tomato or not. And so yellow shouldering, I wanted to ask about that one because I think there's a genetic basis, like your like green shoulder tomatoes. I think, correct me if I'm wrong, but I think there's like that's something that has an actual genetic basis. Like people, I think green shoulder tomatoes. Some tomatoes, when they're unripe, have this really pronounced green shouldering, and then some tomatoes that don't have that pronounced green shouldering is like there's a genetic basis for green shouldering or not, and that it's the tomatoes that have green shouldering to where it's really prominent when the fruit is unripe. My understanding is that was green shouldering was selected against in the industry because tomatoes with green shoulders were more likely to get yellow shouldering or later on, as far as like if people don't know what I mean by that, would you say it's just like an uneven ripening where like, the tomato looks good until it gets up to the shoulders and then it's kind of like yellow shoulder, it's like basically the shoulders don't ripen evenly. Is that right? That there's an actual genetic basis to that one?
Yeah, the presence or absence of that type of green shoulder is actually a single gene, and the name of the gene is U for uniform.
Oh, okay.
Because tomatoes without that green shoulder gene, the ripening of the fruit is much more uniform, and obviously that's much better for like a industrial, like farming and food chain, to have fruit that ripens uniformly and when it's on the supermarket shelf looks totally red, etc. Right? The green shoulder itself, though, actually is green because it has chlorophyll. It's actually photosynthesizing. So scientists have realized that the varieties that aren't uniform ripening, that do have that green shoulder gene, they actually have a higher amount of sugar in the fruit than varieties without the green shoulder gene. So pretty much every heirloom variety is going to have that green shoulder gene. People probably, have selected for it because it results in higher quality fruit, better tasting fruit, although there's a trade-off with the uniformity of the ripening, right? Yellow shoulders is a defect that you can have on varieties with that green shoulders trait or without the uniform ripening trait. And that can be caused, my understanding, by a few different things. Like potassium deficiency can lead to yellow shouldering. I think that can be common in high tunnels or greenhouses where plants are putting out a lot of fruit and, they need the nutritional demands to kind of meet the output of the plants. But also some environmental stress, like high temperatures, can lead to yellow shouldering. And there's also definitely a genetic basis to sensitivity to that as well.
Okay. Interesting. I feel like I've been told that tomatoes with that green shoulder gene, where they're photosynthesizing on the top, are more susceptible to yellow shouldering. But
I think that might be the case. There are some heirloom varieties. I think Cherokee Purple is an example where when the plant is stressed, those green shoulders never ripen. They stay hard and green, or maybe ripen to a yellow color instead of the, like dark brown or purple color that Cherokee Purple has. So yeah, I don't know, I can't necessarily answer definitively, but there might be an association between those traits.
Okay, yeah, that's what I've been told, and that's why I brought it up. Okay, but that's interesting because I've noticed that hard green shouldering that you just described in the Cherokee Purple, and I never knew what that is. So okay, good. And even I'm even wondering if yellow shouldering has a climactic factor as well, because I was actually a couple months back we ran a article in the magazine about someone talking about how the things they were trying to do to improve their soil health, one of their challenges being yellow shouldering. And I was talking to a guy who gets the magazine and is very experienced in this kind of stuff, and he said, well, that's because he said that tomatoes don't take up potassium very well below 55 and above 83 or something like that. And honestly, I don't know whether he's right or not. I hadn't heard that before. On the other hand, the thing is, tomatoes don't really want to be below 55 or over 83. And so whether he's technically right or not, it's just I feel like it's like a human, like we wouldn't do if we had to sit in an office and work in 32 degree temperatures or 105 degree temperatures, we wouldn't work very well. So if anybody knows about there's an actual thing with potassium not being very mobile when the plant is too cold or too hot, call me. Let's do a podcast interview about it. But on the other hand, like, it makes sense. Like, those are basically like temperatures that tomatoes will survive at, but aren't very happy at. And so I don't doubt that there's a lot of things that go wrong. Like, I mean, that's the whole point of climate control, or like growing them in the right environment, is so that they stay in the region where they're happy, because that's when all their biological processes tend to like work.
Right.
Pretty well. So, okay. I just wanted to ask that. Somebody just told me that the other day. I wanted to run it by you, see what you thought. So, okay. One other thing that I wanted to ask you about was flavor potential, because I know a lot of people think of heirlooms as like the best tasting tomatoes, and like you said, flavor is so subjective. Like that is such a hard thing to get a read on, because one person's perfect tomato will be someone else's least favorite tomato. And so one of the approaches that I always thought was that whether heirlooms are the best tasting or not, no plant is going to taste at its peak when it's diseased. And so I thought, like, one of the advantages of a Hyloom is that if the longer the plant stays healthy, the better the fruit is going to taste. And so one of the anecdotes from my experience that comes to mind is like dealing with leaf mold in a greenhouse, where we had half greenhouse types, and that all had leaf mold resistance, and half heirlooms. You probably know where I'm going with this, is that like at this point, leaf mold resistance is pretty perfect. As far as, if people are familiar with leaf mold, like, it tends to be the kind of thing, like, a lot of people get a honeymoon, like a few years without it, and then like, that's what happened to us. I think we grew tomatoes for 3 years in a hoop house and no leaf mold, and it was like year number 4 it showed up, and from then on we had it every year. And so we would have these greenhouses that had some heirlooms in them, and the heirlooms would just be covered with leaf mold, and would eventually take them out. So, we would have greenhouse varieties right next to them, not a speck of leaf mold on them. Like, that disease resistance is working 100%, because they're in a greenhouse with infected varieties. Those spores are blowing around in there. The greenhouse varieties don't have it. The heirloom varieties they don't have it. And so, of course, as leaf mold is taking over the leaves, so it's basically like messing up the solar panels of the plant, as it progresses until it kills the plant. Those last heirlooms that we picked were probably not at their peak flavor, just because they're diseased. And so I know there's, like, I've read a lot by a tomato grower in North Carolina who has a similar thing going on, who has grafts all his heirlooms because he has like verticillium and all the other soil diseases. So this can work for either leaf diseases or soil diseases, but the point being that if it doesn't really matter how good the flavor potential of your variety started out with. It doesn't matter if you're growing like Brandywine. If half of the leaves are non-functional because they have leaf mold, or if the half of the roots are dead because of verticillium, it's not gonna perform to its peak. So I guess I just wanted to, well, both say that, because I feel like that's an important part of the context, is that like, the longer you can keep your plants healthy, the longer they're going to taste good. So even for people whose top criteria is good tasting plants, which, like, among market farmers, that's very important, right? Because your customers don't care like how much you're picking. They're going to come by from the farmer's market stand that has the best tasting tomatoes, right? So,
right, exactly.
And like, also the like improved varieties or Hylooms are going to cost more than heirloom seed. But at the same time, I figure that them staying healthy is priceless, in that they'll stay tasting good for longer. And I figure, I can't remember if I mentioned this, but when we were growing true heirloom varieties and greenhouse varieties in the same greenhouse, we got about half of the yield, like marketable yield, like number one. It's like, yeah, I didn't take as good notes as you did with like what all the defects were. We pretty much like just sorted them really quickly into like number one. Yeah, but we kept records. Well, both because we are organic certified and had to, but because we wanted to know, like, we want to know, like, if any variety really isn't a yielder. But that was my thought, is that not only, like, your customers will appreciate the fact, like, the work that you're doing to get disease resistance into these varieties. I mean, they won't know to thank you for that, but they'll know it when their tomato tastes good. And then as far as the farmer's concerned, I figure, yeah, like, Hylooms, any hybrid for that matter, is going to be more expensive, the seed is, than an open pollinated true heirloom. But if I figure if a farmer picks one more tomato off of a plant versus like the plant dying, going down to some disease, like that one tomato will probably cover the difference and then some between like, Hyloom seed and heirloom seed. And then any other tomatoes you get off that plant is just like profit, beyond that. So I guess like, I don't know. I just, I think people should grow the varieties they want, but I think it's worth growers trialing those varieties just because even though they're more expensive at the beginning of the season, the disease resistance in particular will probably pay off over the course of the season.
Right. Yeah, I think that's a really good point. And that's consistent with all of my observations over the years. And I've both, as a gardener and now as a professional tomato breeder, eaten a lot of tomato fruit from varieties that have potential for really good flavor that do not taste well because I've done a bad job growing the plants, and the plants are unhealthy and stressed. The plant health and flavor definitely go hand in hand, right? So disease resistance is one of those things. Like you said, if the plant is like completely senescing because it's the end of the season and it's covered in leaf mold, it's not going to be putting out good quality fruit. And then in terms of the seed cost issue that you brought up, F1 tomato seed, these Hyloom varieties, the seed is definitely expensive, much more expensive than open pollinated tomato seed. I do think that difference in cost is made up for the increased marketable yield that you would get from them, unless you're like really good at growing heirloom varieties, which I think there are people out there who are really good at doing that. But yeah, I think in most cases the number of marketable fruit you would get would compensate for that difference in price. The reason that F1 seed is so expensive is because it's expensive to produce. Every single F1 tomato seed comes from a manual cross-pollination that someone made. Like they manually took a tomato flower on a plant, removed the anthers before they shed pollen, grabbed pollen from the other plant that they're pollinating with, applied it to the stigma of that plant, and then harvested the fruit of that plant. Every single F1 tomato seed comes from a flower that had that process done to it.
I'm so glad you made that point because it is a tedious process too, right? I mean, it's like tweezers, like little magnifying, perhaps little magnifying things, it's a painstaking process. So
definitely
there's a reason that it costs what it does. Okay. So am I correct that if you bred a variety that you thought would be useful to farmers, you've done all this work and you're like, all right, this one's a winner, that you would seek to commercialize it? And if so, what does that process look like? Like once you think you've got a good one?
Yeah. So I talked about this a little bit in terms of how varieties and genetics make their way, out of Cornell or out of universities into farmers' hands.
Right. And if you covered it, that's fine. Sorry. I know you talked a little bit about like the whole licensing process. Feel free to say like that's it. But I guess I was wondering, like, would you try to, if you had a variety you thought was like finished, could be commercialized, would you shop it to seed companies? And like, how does that go?
Yeah, exactly. So we have relationships with seed companies. We have an annual field day where seed companies can come and look at what we're doing. Not just myself, but other vegetable breeders who I collaborate with. I'm part of a group of vegetable breeders, and there's opportunity for them to look at the material in the field, talk about it, learn about the work we're doing. We get to learn about what they're interested in, what they're looking for. And if there's something that fits their needs, right, like meets, demand that they have from their customers, and then they can license it from us. And like I mentioned earlier, if it's a finished variety, a finished hybrid, they can either sell it directly, or if it's something that maybe needs a little bit more work, they can cross with it themselves and keep selecting, but select for some of the traits that we may have selected for. But that's basically how the process works. I mean, at some point, the variety leaves the research fields and gets evaluated on farmers' fields. That can happen either on our end or on the seed company's end, or realistically probably both. But that's a really important part of the variety development piece, is trialing with actual growers and seeing how it does, under their conditions.
Okay, cool. All right. Well, that's really the questions I had for you. I just peeked at my watch. I realized we've been talking for quite a while, and like, I'm not surprised. I'm a tomato nerd, so like could probably keep going. But like I like that's pretty much what I wanted to ask you about today. And so I just wanted to ask you if there's anything else that I should have asked you about, or anything that you'd like to say before we let you go.
I don't think so. It was a nice conversation. We ended up talking about genetics a lot more than I expected. I wish I had like prepared some way. I probably just was rambling about how this whole process works, but no, it was a great conversation. It was great talking to you.
Yeah. Well, no, come on, you're a tomato breeder. I think you're always prepared for some. I thought that was great. Like I learned a lot, and I think our audience will learn a lot from that too. So yeah, maybe, I don't know, maybe that conversation. Yeah, actually, I think we did end up talking about genetics a little bit more than I intended. On the other hand, I feel like a lot of the value of these podcasts comes from the like responses and the follow-ups and where the conversation takes us. So I don't know. I really enjoyed it. I suspect that our audience is kind of nerdy and like wants to know, like, what I always think is like the why behind the why. It's like
yeah,
like, well, why does a tomato get catfacing? Well, because there's a problem with the blossom end. Like, well, why is there a problem with the blossom end? These things, and that's what we just talked about. So I am just as happy that the conversation went in that direction. I appreciate you. You've been very generous with your time. I appreciate you talking about all that with us. I'm glad you're doing this work, just because, as long as you can preserve the good flavor of heirlooms, I think it's a real service to farmers to have varieties that have the flavor and that also have the disease resistance and the other traits that are just going to make them grow better, live longer, and be more marketable. And as we talked about with the diseased heirlooms can actually taste better because they're not diseased. So
exactly.
All right, so I really appreciate your time talking to us today, and also your efforts trying to make better varieties for farmers. So on that note, where can people find you online or social media or wherever you want people to look you up?
So I don't have a big social media presence. The best place to look me up would be my Cornell faculty page. You can find by Googling my name. Soon we will have a website up with more information about our breeding work and our extension work, including the results of these trials that I talked about. It's not online at the moment, but if you give us a few months, hopefully it'll be there and you can find that information then.
Okay, I feel you. We just had to redo like our website and pretty much like all of our systems here at GFM, and it takes a while. I know you're probably in a very busy season as far as like getting things probably either ready or planted out in the field, depending on your season there. So yeah, I feel that. Well, all right. Thank you, Greg. I've had a really good time nerding out about tomatoes with you.
So have I.
And thanks again for the time and the good work that you do.
Thank you, Andrew. I really appreciate it.
Thank you for joining us for this episode of the Growing for Market podcast. If you've been enjoying the show, please consider giving us a follow and a rating or a review. It really helps others find the podcast. For more tips and tricks from farmer to farmer, check out our magazine at growingformarket.com. Whether you're a commercial grower or just want to grow like one, subscribe to Growing for Market magazine for the nitty-gritty of growing, marketing, and the business of market farming. We publish 10 issues per year with articles written by experienced farmers on topics ranging from tools and techniques to farm business operations and marketing. If you've been listening to the Growing for Market podcast and haven't yet checked out Growing for Market magazine, we've made a change so you can try the magazine for free. We've added a free month to the beginning of all first-time subscriptions. Try out the digital or paper magazine for a month, and if it's not for you, cancel within 28 days and you'll never even get billed. All subscriptions get you a year of the magazine, plus 150 downloadable back issues from the last 15 years and over 1,700 archived articles. With digital subscriptions starting at just $39 a year, head on over to growingformarket.com and subscribe today to benefit from over 3 decades of writing by farmers, for farmers, in Growing for Market magazine.